Okay, here we have the limit as x approaching 0 plus of x to the square root of x power. And if we put 0 into here and here, we get 0 to the 0's power. Unfortunately, this is an indeterminate form because it's on my shirt. So we will have to do more work. We cannot draw any conclusion yet. So what do? Well, I will show you guys two ways to write out the work. The first way is, because we have a function to a function power, so it's a good idea to let's just call this to be L for limit. And let me just write that down. And the idea is that we would like to utilize the natural log. Because again, a function to a function power, we want to take the natural log. But before we can do that, we must have an equation. And then just go ahead and proceed. Take the natural log on both sides. It's kind of similar to logarithmic differentiation. You take the natural log on both sides first. So keep in mind the left hand side is ln L, keep that in mind. And then for the right hand side, we have natural log of the limit. What we can do is actually just switch the limit and also the natural log, because natural log is a continuous function. So that's a detail. So this right here is the same as saying the limit as x approaching 0 plus, and then we have the natural log, and then we have x to the square root of x power. All right? So, yeah. Now, what we can do is just put this to the front. Now that's pretty good. And then we will see this is the limit as x approaching 0 plus, and then we have the square root of x times ln x. Okay, it looks pretty good, huh? But the thing is it? When we put 0 into here, square root of 0 is 0. And then when we put 0 into here, technically 0 plus, ln 0 plus is negative infinity. Oh my goodness. This is again an indeterminate form. The negative doesn't really matter. It's multiplication. So we cannot use L'Hopital's rule yet. And we have to do more work. So this is what we do. Pay attention to the square root of x. Alright, this right here is square root of x. You can actually take either one, but usually when you have 0 and also infinity, if they are multiplying together, just bring one of them down. And this is what I mean. We are going to get the limit as x approaching 0 plus, keep the ln on the top like so, and then over 1 over square root of x. You see? Bring this down. That's what I mean. And when we put 0 plus into this x and that x now, on the top we get negative infinity. On the bottom, well, 1 over 0 plus and positive in the square root and all that stuff, we also get infinity. So this right here is good because now we have negative infinity over infinity, which is the indeterminate form that we want, because we can use L'Hopital's rule. So here we go. Differentiate and then also differentiate. On the top, it's not bad. So this is still the limit as x approaching 0 plus. This is 1 over x. On the bottom, well, let me just show you guys the steps. This one, when we differentiate, let me actually just put it here. When we differentiate, this is like saying x to the 1/2 power on the bottom. So this right here is the same as saying x to the negative 1/2 power. From here, put the power to the front and then minus 1, we are going to get negative 1 over 2, and then x to the negative 1/2 minus 1, we get negative 3 over 2. So that's the derivative for that. And I'm just going to keep this as how it is. Negative 1 over 2, x to the negative 3 over 2 power. Alright, that's pretty good. And now what I'm going to do next is, I would like to just multiply the denominator. So let me multiply the top and bottom by the 2 so they can cancel out. And also I will bring this up, so I will just say multiply this by x to the 3 over 2 power, like this and also like that. This way, this and that can cancel, and this and that can cancel, and we do have a negative. So this is the limit as x approaching 0 plus, and we have a negative. And okay, we have a 2. And here we have x to the 3/2 power, and this is the same as x to the first power. 3/2 minus 1, we get 1/2. Alright, so that's what we have. And then we can just put a 0 into here. So this is -2 times the square root, and then this is the 0 plus, which is just 0. And you know what? We just get 0. However, this is not the answer to this, because this is only the answer to ln L, which is just the limit. So ln L, it's equal to 0. We can do e to this power, e to that power, so they cancel. And ladies and gentlemen, this tells us that L, which is the limit that we're looking for, as x goes to 0 plus, and then we have the x to the square root of x power. This right here is e to the 0th power, which is just equal to 1. Unfortunately, this is not one of the examples that I like, because a lot of people will say whenever we have 0 to the 0, we should just end up with 1, even for limit. But 0 to the 0 does not always give you 1. You guys can check out my other example for that. But as I said, this is the first way of how you can write down the work. If you are satisfied with this, that's it. If not, check out this one. Alright, so what we're going to do for the second way. Here, we still have the limit as x approaching 0 plus. Instead of taking the natural log, well, we are going to rewrite the x. We don't like x for the base, and especially the power is also a function. We like to have base e, especially in calculus. So we'll write this x as e to the ln x power. You see, this and that cancel, we still get the x back. So we are still kind of using ln. Alright, so we have this and then raised to the square root of x power, and now we can just multiply this and that together. So this is going to be the limit as x approaching 0 plus, and we have e to the square root of x times ln x, like this. Well, we are taking a limit, and then the function part is actually here and here, right? We are multiplying this and that. So we can actually just focus on doing a limit right here, and at the end, do e to that number. So right here, we are going to write e for the base, and then we take the limit right here as x approaching 0 plus, and then we have this, which is square root of x times ln x. And this is exactly what we got earlier too, right? When we put 0 into here and here, we get 0 times ln 0 plus is -infinity. So for this part, we will have to do more work, and let's just go ahead and put that down right here. This is going to give us e for the base, and then we have to take the limit as x approaching 0 plus. Keep the ln on the top, like right here, and then rewrite the square root of x down, so we get a 1 over square root of x. And then we see that this part is a part that we can use L'Hopital's rule, because we will end up with -infinity over infinity. So here we go. Based on -infinity over infinity, we can use L'Hopital's rule. We still have e for the base, and then we have the limit as x approaching 0 plus. And then here, do the limit. And we will get the derivative of ln x is 1 over x. And then the derivative of this, remember the answer? Yeah, it's just -1 over 2, x to the -3 over 2 power. So I think if you do it this way, it's more concise. You save some steps. Yeah. Alright, so let's finish it. And we'll do so by multiply the top and bottom by exactly what we did earlier too. So 2. And also x to the 3 over 2 power, x to the 3 over 2 power, so that this and that cancel, this and that cancel. And ladies and gentlemen, we will get e to the limit of x approaching 0 plus 2 times x. And then 3/2 minus 1, we get a 1/2. And don't forget, we still have the negative. And put a 0 in here, so we are going to get e, and then we have -2, and that's the square root, and then 0 plus, which is just 0, e to the 0th power. Yeah. So ladies and gentlemen, the answer is equal to 1. And we did this in one line, so from here all the way here, and then we end up with 1. Yeah, let me know which way you guys like better. Either you call that to be L and then you do the natural log on both sides, Or you just write the base as e to the ln x power and then you continue from there. Check out my other videos for more examples like this.